Okay, so now let's move on to a little bit more sophisticated of an example using the chain rule. And let me not use a marker that matches the color of my shirt. All right, so here we want to take the derivative of this function now with respect to both r and theta. But now it's, not just one variable anymore. And again, this might still be a simple enough example that you could just plug in the x and y's into here and do the derivative. And again, I want to encourage you, don't do that. Let's do the chain rule way first because it's more general and it's nicer to start with easier examples. And again, a good way to verify this, that this is really working, is to actually, after you've done this using the chain rule, go back and verify it the other way. But anyway, let's get to the point. Solution. All right, so we're going to need the same sorts of things as before. Like we're going to need the gradient of f, which this time is 2x minus 2y, and then 2y minus 2x. I reversed the order there, but it's the same thing. Negative 2x plus 2y is the same as 2y minus 2x. All right, and we're going to need to know what is g. Well, g, this time it's a function of r and theta, because we have two new variables. Okay? And this is r cosine theta and r sine theta. All right? So sometimes it's actually a little bit simpler to do the necessary dot product, then replace all the x's and y's at the end. Right? Because sometimes it can get a little messy to plug all that stuff in here right away. Maybe some things cancel. I don't know if I'm not sure if they do here, but they could in other examples. So let's see what that looks like. All right, so if we're going to do, say, dz dr, well, this is going to be the gradient of f dot partial g with respect to r. Okay? So we have our 2x minus 2y, 2y minus 2x, dot product. Now we need to take the derivative of this with respect to r. That's pretty simple. That just gives us cosine theta, sine theta. Okay? Sine theta. All right. And then now we do the dot product. And we have 2x minus 2y cosine theta minus, or plus, 2y minus 2x sine theta. There is a little bit of a simplification we can do. We can write this as 2x minus 2y times cosine theta. Now notice, since this is just the negative of that, this is minus sine theta here. Right? And then now, we can't have x's and y's in the final answer because those are no longer independent variables. Right? So we have to replace those with these two guys up here. Right? And that gives us 2r cosine theta minus 2r sine theta times cosine theta minus sine theta. Right? And that would be the answer. And here, if you like, we can actually go a little bit further, and this will factor to 2r cosine theta minus sine theta squared. Okay? Okay, now let's do the other derivative here. dz d theta, well, this will just be the gradient of f dot product with dg dr, d theta. And I just realized up here there's a vector on the r for some reason. That shouldn't be there, just a regular r. All right. Well, I'll leave this one to you to do all the details for, but we can bring that all the way down to, and in fact, if you're clever with your trig identities, actually let's have that in there. Minus 2r squared cosine 2 theta. You can actually use a trig identity on this and simplify it a little bit too, but for now it's not necessary that you actually do that. But when we're doing some integrals later, it'll help sometimes. So I'll leave it to you to check that dz d theta is actually negative 2r squared cosine of 2 theta. All right? In the next video, what I want to look at is a different, we're going to do the same example, but we're going to do it in a little bit different of a way. Because remember, when we first talked about the chain rule, we noticed this sort of cancellation pattern that happened if we write out the dot product. And in the next video, we'll talk a little bit more about what that means, and then do the chain rule again for this same example. Okay?